Hello dear student, welcome to your new session of current electricity. In last class, we'll discuss about the working of potentiometer and its all application. In that, we'll discuss about the value of, how to find the value of internal resistor of the practical battery. Then we'll discuss how to find the potential across any resistor which is a part of any electrical circuit, and we'll discuss about how to compare the EMF of the batteries with the help of potentiometer. As we all know, potentiometer is more reliable device compared to, my dear student, compared to the voltmeter, because potentiometer and voltmeter both works on similar process, that is finding the potential across any circuit element. Now we'll move forward and we'll make last topic of construction, or we can say last topic for electrical instrument. It is meter bridge. So write down next heading, it is meter bridge. So my dear student, we are talking about now meter bridge. What is meter bridge, how it is works, and what is basically the use of meter bridge. So see my dear student, what actually meter bridge is. First thing, meter bridge working principle. So write down principle of meter bridge. So my dear student, meter bridge works on the principle of Wheatstone bridge. So write down, it works on the principle of Wheatstone bridge. It works on the principle of Wheatstone bridge. So basically meter bridge is nothing but it is working on the principle of Wheatstone bridge. And if you are aware, then Wheatstone bridge will be combination of 5 resistor is called Wheatstone bridge. This is how Wheatstone bridge look like. This is R1, R2, R3, R4 and R5. Let's suppose this point is B, this point is A, let's suppose this point is C and this point is D. If the potential of point C is considered to be Vc and potential of D point is considered to be Vd, then we know that the balance condition of Wheatstone bridge is no current can flow across the bridge resistor. And if no current can flow across the bridge resistor, then we'll say why? Because potential across the bridge resistor is same. So we can say that there is no use of this resistor, remove this resistor. And we all know about the balanced condition of Wheatstone bridge. The balanced condition of Wheatstone bridge is, my dear student, R1 by R2 is equals to R3 by R4. This is the balance condition of Wheatstone bridge. If the ratio of these two resistors becomes equals to ratio of these two resistors, then we'll say Wheatstone bridge is balanced. So meter bridge is also working on same principle, that is it works on principle of balance condition of Wheatstone bridge. Not only Wheatstone bridge, we can say balanced condition of Wheatstone bridge. So remember, this is the balance condition of Wheatstone bridge. It is R1 by R2 is equals to R3 by R4. Next core concept related to meter bridge is, my dear student, as we know, the resistance of conductor is directly proportional to length. Remember, the resistance of conductor is directly proportional to length of the conductor. Resistance of conductor is directly proportional to length of the conductor. So we can say, as resistor is directly proportional to length, so instead of length we can use, my dear student, resistance, or instead of resistance value we can use length of conductor as well. So write down in form of note, instead of resistance, write down in form of note, instead of resistance we can use instead of resistance we can use length of the conductor. Instead of resistance we can use length of the conductor. Instead of resistance we can use length of the conductor. So instead of resistance we can use length of the conductor. Why? Because resistance is directly proportional to, my dear student, length of the conductor. Now moving forward, let's see what is the construction of meter bridge. So write down construction of Wheatstone meter bridge. Construction of meter bridge. Construction of meter bridge. Construction of meter bridge. Construction of meter bridge. So my dear students, see, the name is meter. Meter means 1 meter. Why this instrument is called meter bridge? Because in this instrument we can use a wire whose length is identical and its length is 1 meter. So write down, first point is for making meter bridge. For making meter bridge we can use wire of length 1 meter. Wire of length 1 meter. So my dear student, for constructing meter bridge, remember we can use a wire whose length is 1 meter. Next, see how we can construct a meter bridge. We have to take a wooden frame. This is a wooden frame, my dear student. Wooden frame. In this frame we will tag a wire whose length is 1 meter, or we can say 100 centimeter. So this is the wire whose length is 1 meter, or we can say 100 meter. For constructing meter bridge we have 3 copper strips like this, 2 in L shape and 1 is plain. So 2 copper strips is also used for making meter bridge. So this is nothing but copper strip, my dear student. This is copper strip. One more strip is there. Between these 2 gaps we'll connect resistor. Let's suppose this resistor is R. Let's suppose this resistor is of resistance X, this resistor is of resistance Y, and between this strip we have to connect one end of galvanometer, and other end of galvanometer is connected with a device called jockey, and one battery is also there to operate the circuit. So this is battery. Let's suppose the potential of battery is V. So this is how we'll construct a meter bridge. In meter bridge, my dear student, we have a wire whose length is identical, that is equals to 1 meter. 2 resistors are connected in copper strip. One is of resistance X, other is of resistance Y. And between the resistor there is a copper strip in which one end of galvanometer is connected and other end of galvanometer is connected with a device called jockey. With the help of jockey, as in potentiometer, we can follow the process. With the help of battery, see, there is a battery connected between point A and B whose potential is considered to be V, and my dear student, this A point is connected with positive. Let's suppose this point carry potential VA and this point carry potential VB. Now VA is connected, A is connected with positive, so A carry higher potential, B is connected with negative terminal, so potential of B point, that is VB, is less than VA. Here we can write VA is less than VB, because A point is connected with positive terminal, that is higher potential, B point is connected with lower potential, that is negative. Now see my dear student, how Wheatstone bridge, what is the working of Wheatstone bridge? Wheatstone bridge is basically used to find the resistance of any unknown resistor. So write down, Wheatstone bridge is used, Wheatstone bridge, meter bridge. Meter bridge is used, meter bridge is used to find the resistance. Meter bridge is used to find the resistance of any unknown resistor. Meter bridge is used to find the resistance of any unknown resistor, my dear students. So what is the work of meter bridge? Meter bridge works to find the unknown resistance of any resistor. So let's suppose, let y be the unknown resistance. Y be the unknown resistance. So first step, remember one thing, in meter bridge a wire is there whose length is identical and its length is 1 meter, or we can say 100 centimeter, and two resistors are there, one is of resistance X and other is of resistance Y. This Y resistor is unknown for us. With the help of this setup, that is called meter bridge, will get the value of this unknown resistor whose resistance is which will be considered as Y. This X is known resistor, my dear student, and let's suppose this Y is unknown resistance. So see how we'll find the value of this unknown resistor with the help of meter bridge. Remember one thing, meter bridge works on the principle of balance condition of Wheatstone bridge. Now moving forward, see my dear student, this is a galvanometer, and in previous topics we already discussed that galvanometer is also a kind of resistor, because galvanometer is an electrical device and every electrical device carries some resistance. So let the galvanometer resistance, let the resistance of galvanometer is equals to G. We are considering the resistance of galvanometer to be G. Now see, with the help of jockey, as this wire is connected with battery, let's suppose a switch is there. Now I'll close this switch, means the current starts flowing. The current starts flowing and it will be flow from higher potential to lower potential. Now see, this point carry higher potential and the potential of this point A is VA and potential of point B is VB. Now see my dear student, with the help of jockey, I'll move from point A to point B. As we know, point A carry higher potential and point B carry lower potential, and between point and B, between points A and B, there are infinite number of points and every point carry different potentials. So see my dear student, with the help of jockey, I am moving from point A to point B. Let's suppose I'll get a point P whose potential is, let's suppose, VP. At point P, at point P, galvanometer shows zero deflection. I am considering, my dear student, that at point P, this galvanometer shows zero deflection. So if galvanometer shows zero deflection, what it implies? It implies now no current is flowing across this resistor. Let's suppose from point A and point P, let the distance is L, where galvanometer shows zero deflection. And we know that the point where galvanometer shows zero deflection, that point is called nothing but null point. We know about null point. Null point is that point which is basically where the galvanometer shows zero deflection. So let's suppose at point P, which is L distance apart from point A, where galvanometer shows, my dear student, zero deflection. So if galvanometer shows zero deflection, whose resistance is G, and the length of null point, let's suppose, is L. Now see, the total length of wire is 100 centimeter. If this length is L, then this length must be 100 minus L. So now, as we all know, my dear student, resistance is directly proportional to length. So instead of resistance, we can use the length of conductor as well. So let's suppose this L is considered to be a resistance. Let's suppose this is R1, this is R2. Let's suppose this length is considered to be R3, and this 100 minus L is considered to be, my dear student, R4, because we know that resistance of the resistor is directly proportional to length of the conductor. Instead of resistor, you can use the length of conductor, value of length of conductor as well. So we are considering X to be R1, Y to be R2, L to be R3, and 100 minus L to be R4. Why we are considering L to be R3? Because we know that resistance is directly proportional to length of the conductor. Instead of length, we can use resistance. Instead of resistance, we can use the value of length of the conductor. Now see, first, second, third, fourth. 4 resistors are there, and one more resistor is there, my dear student, which is galvanometer, because we know that galvanometer also carry resistance, and our galvanometer carry a resistance of G. Now see, at point P, galvanometer shows zero deflection. If at point P, galvanometer shows zero deflection, it means potential of this point and this point is same. Now no current is flowing across this galvanometer. At null point, galvanometer shows zero deflection. At null point, galvanometer shows zero deflection. So see, my dear student, 1 resistor, 2 resistor, 3 resistor, and 4 resistor, and one more resistor is galvanometer. We are considering galvanometer to be R5, because we know that galvanometer also is a kind of resistor whose resistance is G. Now moving forward, see, we have to total in this circuit, we have total 5 resistor, R1, R2, R3, R4 and R5, and in R5 no current is flowing. So if 5 resistors are there, and in bridge resistor, if no current is flowing, then we can say Wheatstone bridge is balanced. So what we'll achieve? We'll achieve the balance condition of Wheatstone bridge. Here we have 5 resistors, my dear student. So now in bridge resistor, this galvanometer will act like a bridge resistor in which no current is flowing once we'll get the null point. So we can write here galvanometer will act like bridge resistor. Galvanometer will act like bridge resistor, first point. Next point is, in galvanometer no current is flowing, and if no current is flowing, it implies the Wheatstone bridge is balanced because we have 5 resistors. So we can say no current is flowing in galvanometer. No current is flowing in galvanometer. So if no current is flowing in galvanometer, then we can say Wheatstone bridge is balanced. So what is the balance condition of Wheatstone bridge? R1 by R2 is equals to R3 by R4. Now see, R1 is X, R2 is Y, is equals to R3 is L, and R4 is 100 minus L. Here R3 is considered to be L and R4 is considered to be 100 minus L. Why? Because we know that resistance is directly proportional to length of the conductor. So my dear student, in this setup we have 5 resistors. one is X, other is Y, third is L, fourth is 100 minus L, and fifth register is considered to be register of galvanometer. So we have a galvanometer whose resistance is G, and in galvanometer no current is flowing. So if no current is flowing, then we can say this is a setup like Wheatstone bridge, and in fifth register, which is called bridge register, no current is flowing. So if no current is flowing on bridge register, then we can say Wheatstone bridge is balanced. Similar is Wheatstone bridge is balanced. So we want to find the value of this Y, because this Y is unknown resistor, and with the help of meter bridge we'll get the value of unknown resistor. So reciprocate Y by X is equals to 100 minus L by L. So Y becomes equals to X into 100 minus L by L. This is the value of unknown resistor with the help of, my dear student, meter bridge. So this is all about meter bridge. Remember, with the help of meter bridge we can find the value of unknown resistor. We can find the value of unknown resistor. Second thing is Wheatstone bridge, meter bridge works on the principle of Wheatstone bridge. And one more thing you have to remember is resistance is directly proportional to length of the conductor. So instead of resistance, we can also use the length of conductor if length of conductor is given. So this is all about, my dear student, meter bridge. So this is up to what we will have in a form of electrical instrument in this chapter. Now moving forward, write down next topic, heating effect of current. Write down heating effect of current. Next topic is heating effect of current. Heating effect of current. Next topic is heating effect of current. So here comes your heating effect of current. So let's discuss heating effect of current. My dear student, this heating effect of current is also called Joule's law of heating. So write down heating effect of current is also called Joule's law of heating. Joule's law of heating. Joule's is a scientist. He'll give a law, that is, let's suppose we have a resistor whose resistance is R, in which I current is flowing, and let's suppose this resistor carry two ends A and B. Let's suppose potential of point A is VA and potential of point B is VB, and let's suppose VA minus VB is considered to be V. So here we have a resistor whose resistance is R, in which I current is flowing, and across the resistor the potential is V. So Joule's can give law of current heating, or we can say heating effect of current. He says that if current is flowing in any resistor whose resistance is R, and across the resistor if potential is V, then first law related to Joule's is, or we can say Joule's law of heating. First law is heat. Remember one thing, my dear student, there is two words, one is dissipated and one is we can say dissipated. So the heat which is dissipated by the resistor, two things are there, one is dissipated and second is developed. Resistor always dissipate the heat. Dissipate means waste. So we can say the heat dissipated by the resistor is given by Joule's law of heating. So write down the heat dissipated by the resistor. The heat dissipated by the resistor. The heat dissipated. The heat dissipated by the resistor. The heat dissipated by the resistor in time t is given by joules. law of heating. Joule's law of heating. So remember, if we have a resistor whose resistance is R, in which I current is flowing, then and across the resistor, if potential difference is V, then the heat dissipated means wastage. So dissipated by the resistor is given by law called Joule's law of, dear student, heating. So there are three laws. Write down first law. First law is the heat dissipated by the resistor is directly proportional to square of current. Heat dissipated by the resistor is directly proportional to square of current. Write down the statement of first law. The heat dissipated by the resistor, is directly proportional to square of the current, is directly proportional to the square of current which is flowing in resistor, directly proportional to square of current which is flowing in resistor. Second law is, my dear student, second law says the heat dissipated by the resistor is directly proportional to its resistance. So write down the statement of second law. The heat dissipated by resistor is directly proportional to resistance of the resistor. Heat dissipated by the resistor is directly proportional to resistance of the resistor. Moving forward, let's talk about third law. So third law says the heat dissipated by the resistor is directly proportional to time in which current is flowing. So write down heat dissipated by the resistor is directly proportional to the time in which current is flowing, in the resistor. Now see, my dear student, this is what Joule's law of heating is. First law is heat dissipated by the resistor is directly proportional to square of the current which is flowing in resistor. Second law, heat dissipated by the resistor is directly proportional to resistance of the resistor. And third law, heat dissipated by the resistor is directly proportional to time in which current is flowing. So H is proportional to I square, H is proportional to R, and H is proportional to 2T. Now we'll combine all the three equations. So I am writing combine equation 1, 2 and 3. So we'll write H is proportional to I square RT. Now we know if we want to remove the proportionality, we have to introduce a constant. So here, my dear student, constant is K, whose experimental value is 1. So K is heat constant, and its experimental value is 1. So K I square RT. So we can write H is equals to I square RT. This is what Joule's law of heating is. H is equals to I square RT. This is what Joule's law of heating is. H is equals to I square RT. I hope you all understand, my dear student, Joule's law of heating and use of meter bridge. Remember, if a resistor whose resistance is R, in which I current is flowing, across them potential is V, then the heat disappeared by the resistor is considered to be Joule's law of heating. In Joule's law of heating, in first law, Joule says H is proportional to I square. In second law, Joule says H is proportional to R, and in third law, Joule says H is proportional to T. If we'll combine all the three equations, we'll get H is proportional to I square RT. I is current, R is resistance, and T is time. So what we'll get? We'll get H is equals to I square RT. This is basically Joule's law of heating. Now see, my dear student, sometimes according to question the values is not given. So let's suppose will now make different formulas for Joule's law of heating. So write down different formulas for Joule's law of heating. Different formulas for Joule's law of heating. So the basic formula of Joule's law of heating is H is equals to I square RT. Now see, if current is not given, first case, let's suppose if current is not given. So my dear student, if current is not given, then remember one thing, we know that V is nothing but IR, so we can write I is equals to V by R. So instead of I, we can write V by R. So what we'll get? H is equals to I square RT. Instead of I, we can write V by R. So V by R and is square into R into T. So H becomes equals to V square by R square into R into T. 1 R and 1 R get cancelled. So we'll get V square by R into T. V square by R into T. We'll get H is equals to V square by R into T. So this is one more formula of Joule's law of heating. Moving forward, my dear student, we are discussing now case second. If resistance of resistor is not given. Let's suppose resistance of resistor is not given. So if resistance of resistor is not given, then what we have to do? Let's see. If resistance of resistor is not given, then we know that the basic formula of heat dissipated by resistor is I square RT. Now R is not given. So we know that Ohm's law is V is equals to IR. So R is equals to V by I. So instead of R, we can write V by I. So H is equals to I square into V by I into T. 1 I get cancelled. So H is equals to VIT. So this is one more formula of Joule's law of heating, or we can say heat dissipated by resistor. So we have total 3 formulas. First formula, heat dissipated by resistor is I square RT. Second formula, H is equals to V square by R into T. And third formula, H is equals to VIT. So remember all these formula, the heat dissipated by the resistor, if the flow of current is I, resistance of resistor is R, potential across the resistor is V, then in time T, the heat dissipated by resistor is either I square RT, or we can say V square by R into T, or we can say VIT. So I hope all of you understand now what actually Joule's law of heating is, or we can say heat dissipated by the resistor in time T whose resistance is R. So remember all the 3 formulas. According to the situation, we'll use one of them. I hope you all understand today's lecture, meter bridge as well as Joule's law of heating. In meter bridge, we'll see that meter bridge works on the principle of balance condition of Wheatstone bridge. It is R1 by R2 is equals to R3 by R4. And in meter bridge, remember why this meter bridge is called meter bridge? Because in meter bridge, we'll use a identical wire whose length is 1 meter, or we can say 100 centimeter. And what is the basically work of meter bridge? Meter bridge is basically used to find the unknown resistor resistance. So thank you so much, my dear student. In next class, we'll discuss some more topic. I always tell you, now we are very close to complete this current electricity chapter. So thank you so much, my dear student. Stay safe, stay at your home, work hard, make proper notes, try to practice the numericals by your own related to every topic. So thank you so much. We'll meet on next class. Take care, beta.